So, okay, good morning to everyone. So, in the previous class, we have seen the carrier sense multiple access with collision detection, that is CSMS-CD. So, today we will see carrier sense multiple access with collision avoidance, that is CSMA-CA. So, before this, we will know that where the CSMA-CA it is used. Now, CSMA-CA is basically designed for the wireless network. This CSMA-CA is basically designed for the wireless network. So before seeing the flow diagram or the working of the carrier sense multiple access with collision avoidance, we have to remember some of the variables that are used here. So there are three variables that we have to remind that. Now these three variables are IFS and IFS contention window and the acknowledgement, these three variables. So before starting the flow diagram, what these three variables are. Now first is IFS. IFS is the interframe space. So it is actually a period of time. That is, it is actually a period of time. Here the station first wait for IFS amount of time still after finding the channel ideal. So in CSMS-CD, we have seen that if each station wants to transmit, it sends the transmission channel first. So why this transmission, each station sends the transmission channel first? It is used for sensing that the transmission channel is busy or not. For that, each station first sends the transmission channel. In CSMS CD, we have seen that. So same way, CSMA CAV also works like that. But here, what is this? That before, after sensing the transmission channel, it waits for an amount of time again, because after sensing the transmission channel, it waits for, if the if after sensing it found, the station found that the channel is ideal, then also what? Then also it wait for some time. This time is called the IFS time. So that is here it is written that the station first wait for IFS amount of time. IFS means interframe space. Interframe space amount of time. Still after finding the channel ideal. That means each station first what will do? Each station first sends the transmission channel. If sensing the transmission channel, it knows that the transmission channel is free, then also it wait for IFS amount of time, interframe space amount of time. And after that, again sends the transmission channel. So if this time it also receives that the channel is ideal, then only it can sense the frame. This is the difference between carrier sense multiple access with collision avoidance and collision detection. In collision detection, what is happening? In collision detection, that after sensing the transmission channel, station does what? If it is ideal, it immediately sends the frame. But here, after sensing, if it is found that the channel is ideal, then also the station will wait for some amount of time. This amount of time is the interface space amount of time. So after waiting this interface frame space amount of time, it will sense the channel again. And after sensing the channel, what it will do, if this time also that it found that the channel is ideal, then only the frame can be sent. So this is what the interframe space time. Now, why this is used in this channel? It is used to define the priority of the station of a frame with the use of the IFS. Generally, through the IFS, a station or a frame priority is decided. So that means which station has the highest priority, it will use less amount of IFS time. But the station which immediately wants to send frame, they will what? They will use small IFS amount of time. But other than the station that wants to immediately sense the frame. This is basically the interframe space time concept. That means in this used to define the priority of the station of a frame, and with this use of define the priority of the station of the frame with the use of the IFS. So that means generally through IFS, a station or a frame priority is decided. That means which of the less IFS time, that means its priority is high, that station priority is high. In which respect the station's priority is high? To sending the frame. So if those station use less IFS time, its priority is high to send the frame. But which are using much more IFS time, its priority is not so much high. It can sense the frame after some time. So this is what are the interframe space time. Now, if this is written that if IFS small, that means the priority will be much more. Because if the IFS will be small, then it will try to send the frame immediately. But if the IFS will be much larger, that means there is not so much needed to send the frame right now. So it will wait more number of time, more IFS time. Okay, so this is the concept of the IFS. Then the second variable, that is the contention window. Now, what is the contention window? Contention window is the amount of time divided into slots. Means the time will be divided into slots. This occurs when the station finds the channel busy. Now, this contention window is what about that? It is the time divided into slots. Means the division of the time into slot. And this happens when the station finds the channel is busy. We have seen the IFS concept when the channel is ideal. But contention window happens, contention window situation occurs when the station finds the channel is busy. When the channel is busy, it doesn't restart the timer of the contention window. That means there will be a timer present in the contention window. It doesn't start that timer. It stops the timer and restart when the channel become ideal. So that means when this situation occurs that the channel is busy, then it will not start the timer of present in the contention window. It stops the timer. And when it will restart, when the channel will ideal, it restart. That means that station A, like there are 4 stations present, station A, station B, station C, and station D. So at first time, when station A sends the transmission channel, then it finds that the transmission channel is busy. Then what it will do? It will wait for some time. So that means at first time, it waits one amount of time. So after one amount of time is completed, it sends the transmission channel again. But this time also, what has happened? It finds that the transmission that is busy. That means any other station is transmitting now. So that means it now assume that it will wait for 2 amount of time. So after waiting 2 amount of time, it will again sends the transmission channel. But this time also it finds the busy. Then 4 amount of time it will wait, and after 4 amount of time it will sense the transmission channel. Now it receives that the channel become ideal. So that means it will start the timer and started the transmission of the frame. So this is what the contention window is used. This is the concept of the contention window. And the third is the acknowledgement. This is all, are you familiar with the acknowledgement you receive? That means acknowledgement is received for whenever the sender sends the frame to the receiver, then receiver send 2 type of acknowledgement. One is the positive and another one is negative. If the positive acknowledgement received by the sender, that means what? The sender will know that the frame it has been transmitted are correctly received by the receiver. But if it receives the negative acknowledgement, that means what? If receiver sends the negative acknowledgement, that means the frame is sent, the frame that is sent from sender to receiver is not directly, or we can say it is not rightly received by the receiver. That means this frame can be damaged, or can be what? Can be damaged or corrupted. That's why receiver is sending the negative acknowledgement. Don't compare with that. There is also a situation the sender will doesn't receive the acknowledgement signal, because if the transmission that sender is sending some frame and it is lost in the midway, then what? Receiver doesn't receive anything, doesn't receive the frame. So receiver will not what? Receiver will not send any acknowledgement. That is the concept. Okay. So mainly we have received 2 types of acknowledgement, that is positive acknowledgement and negative acknowledgement. Positive acknowledgement means our transmission is very good and there is no error occurred and receiver received the message correctly. So that's why it sends a positive signal, positive acknowledgement signal. But negative acknowledgement means it is corrupted, and that's why it is the message it is received, or the frames that is received by the receiver is corrupted or damaged. So that's why receiver sends the negative acknowledgement, means receiver want that particular frame to resend again by the sender. This is what the negative acknowledgement concept. So these 3 variables concept are clear? Everyone?
Yes, sir.
Okay. So these are the 3 variables concept. Now we will see the flow diagram. Now we will see the flow diagram. Like in CSMA CD, we have seen the flow diagram. Same as that for CSMA CA, we have also the flow diagrams present. So first, one by one, we will see what are the meanings of the flow diagram. So this is the first stage, that start phase. In start phase, after starting, there is a variable that is k equal to 0. Now, what is k? K is the number of attempts made by the station to transmit frame. That means each station will what? Each station will attempt to send the frame, but some situations will occur there that the transmission channel is busy. So that means it will wait for another time. So wait for time, and after waiting for time, it will send the frame. So that means what? First attempt, the sender doesn't, or the station A doesn't able to send the frame. So that's why it wait for some amount of time, and after waiting for some amount of time, it sends the transmission channel again. So that means what? This is the second attempt of the transmission, second attempt of the station A. So that means what? That's the what number of attempts to send the transmit frame. So at first, it is first transmission. So k equal to 0. That means what? First time it is happening. So the number of attempts is what? 0, because each time there is no first time we are transmitting the frame. So that's why it is received k equal to, it is set k equal to 0. Then what it will do? It will sense that the channel is ideal. This is done by the station that checks that the channel is ideal or not. So if the channel is ideal, then what it will do? That if the channel is ideal, then station not directly sends the frame immediately. It will wait for IFS amount of time. What we have said, that it will wait for IFS amount of time, means extra time. This is the interframe space time, interframe space time. So after receiving that, the sensing the channel, the station receives that the channel is ideal, it's okay, but that is also it waits for an IFS time. And after waiting the IFS time, it will sense the channel again. And this time also, if it finds that the channel is still ideal, if it finds that the channel is still ideal, then it choose the random amount, random R between 0 to 2 to the power k minus 1. This is what? Random variable R. It will choose the random variable R, that is 0 to 2 to the power k minus 1. It is the size of the contention window. Means it is the size of the contention window, that is 2 to the power k minus 1. But if in this portion, if it sends that the channel is ideal, it receives no. That means after sensing, it finds that the channel is not ideal. Then what? It will again sense that the channel is ideal or not. After waiting for some time, it will again sense the channel is ideal or not. And here also, after waiting for IFS amount of time, it finds that the channel is ideal. No, if the channel is not ideal, then again you see, this is what we have done, that it will again sense the channel is ideal or not. After waiting for a time, it will again sense the channel. So this is the way. So, but we are saying that we have find it. The channel is ideal. We have found that the channel is ideal. Then it will choose what? It will choose a random R, a value R between 0 to 2 to the power k minus 1. This is the contention window size, the maximum contention window. It will wait for the R slot. Now, after each slot, what it will check? Each slot, the channel is ideal, then continue. That means there will be a number of frames. So that means each slot, it will check that the channel is ideal, then send that the channel is ideal, then send the frame. So this process will be continued. But if the channel is busy, then halt. That means wait and continue when ideal. That means if it finds that the channel is busy, then pause it. After pausing, then continue. When we will continue that? When it this is sends the frame. So wait for art slots, for waiting for the art slots. And in this, what will happen? After each slot, the channel will be checked that it is ideal. If it is ideal, then one by one frames will be sent. But if it is busy, then the halt will be occurred. The halt process will be occurred. So busy, if the busy, then halt and continue when ideal. So that means the frames will be sent of that. Now, the main process is when the sender is sending the frame. That means when the from stations A, the frames are sending, that means station A is the sender. So there will be another station which is receiving that frame. So that means the receiver, that station will be the receiver. So what we know, that sender will send the frame one by one to the receiver, and receiver will what? Receiver will send the acknowledgement. That is what we have seen during our sliding window concept. During the case of the sliding window concept, we have seen that what? Sender will send the frame one by one, and receiver will do what? Receiver will receive the frame and sends the acknowledgement. And for receiving the acknowledgement to the sender, there is some time period present. If you remember, I have said that there is an each frame time period. Within this time period, if the acknowledgement received, then it is okay. Because after sending the frame to the receiver, there is a time period present. Within this time period, each frame has a time period. Within this time period, the acknowledgement received, then it is okay that my transmission is correctly done and it is received by the receiver. But if it is not received by the receiver correctly, that means it is lost or damaged or corrupted, any of these situations are occurred or happened, then what we will do? We will use k equal to k plus 1. This means we are again second attempting that k equal to k plus 1. That means we are attempting then again. That's why it is k equal to k plus 1. At first you see it is 0. So that means 0 plus 1. Now k becomes 1. So it is the second time attempt. So second time attempt, this process will continue. But before that, k equal to k plus 1, it means that it will be what? It will be now becomes k equal to 1. So if k equal to 1, this will check k is greater than 15. That means it is mentioned here that if the number of attempts are greater than 15, that means it will be aborted. The transmission of the frame, that what the transmissions of the frame going on, it will be aborted if the number of attempts are greater than 15. But if for the IFS time, find that the channel is still ideal or not, and after that choose a random value and wait for the R slots, then sends the frame. After sending the frame, it wait for the some time period, and if inside this time period acknowledgement received, it is okay. But if it is not received within that time, that means we have to again use the second attempt. So that's how this process will be continued. Clear to everyone?
Yes, sir.
Okay. Afrin, Ujjal.
Yes, sir.
Okay. और तुम लोग का गोल्डन गौतम?
Yes, sir.
Yes. Okay. So the basic difference between CSMS CA and CSMS CD is what? It is collision detection, and it is what? Collision avoidance. So this is the two flow diagram. Always try to remember this flow diagram, because practice this flow diagram. If you practice this flow diagram, then step by steps, then how you see, I have explained this from this diagram. So if you remember this diagram, whenever in the exam, if it is given to write the CSMA CD or CSMA CA principle, then directly do what? This diagram first, draw these two diagrams. So after drawing these two diagrams, try to explain each steps by steps. If you explain it steps by steps, then it will be very much clear to you. So fully what? Clear the diagram, because if the diagram is clear to you, then you can able to explain it. Okay, so this is what our CSMA CA. So that means till now we have covered the first module and second module. If you see, then we have covered the first module and second module. First module is about the physical layer concept. Second module is also our data link layer concept. So that means in the third module, what we will see, if you remember the WSI model, then what is the third level from top to bottom? From bottom to top. What is the third layer? Anyone? Anyone can tell me what is the third layer from OSI model?
Network layer or transport layer?
Yes, network layer. So that means what? We have till now, all this happens where? All this happened in the data link layer. This all CSMA CD, CSMA CA, all these protocols are in what? All these protocols are in our second layer from bottom to top, that is data link layer. Your total networking syllabus is what? Is this total networking syllabus, the total 7 OSI layer which are given. Inside this 7 OSI layer, your total syllabus is completed. Inside this 7 OSI layer. So OSI layer is very much important. You should remember that. And I have also said some tricks to remember that. Also said some tricks for remembering that. And also these tricks also you can remember some tricks. Another trick is also there. That is, if there is a Hindi word, you can say, आओ पढ़ो सेमिस्टर तुम्हें नाचा देगा पढ़ते पढ़ते. आओ पढ़ो सेमिस्टर तुम्हें नाचा देगा पढ़ते पढ़ते. आओ means first if we ऊपर से हम लोग देखें तो आओ means application layer. Semester means session layer. तुम्हें transport layer. नाचा देगा in network layer. Then देगा D है data link layer. P है physical layer. और last जो P है वो फ्रेम को हम लोग डालने के लिए, ऐसे जो इडियम से उसको डालने के लिए हम लोग ये यूज करते हैं. इफ यू रिमेंबर दिस ना, तो you will able to remember always the 7 layer according to it, because didn't mismatch whenever you remember this, whenever you have asked, because it is very much important that whenever you have asked this, always try to say according to its order, either from top to bottom or from bottom to top, according to their order. What I have said here, it is from top to bottom. But if you said from bottom to top, then it will be physical layer, then data link layer, then network layer, then what? Transport layer, then transport layer, then sessions layer, then application layer. So from bottom to top, it will be like this. Okay, so always try to remember these layers of the OSI model. Okay, so now we will see whatever we have seen till now in the lab classes, that we have seen the concept of many connecting devices. We have seen the concept of the many connecting devices, that we have seen the router, we have seen the repeater, hub, bridge. So why the connecting devices are required? Now, if you see, this is a LAN. This is a LAN. And in this LAN, there are the systems connected one by one. The systems are connected here, and this is the isolated LAN. So that means this LAN, inside this LAN, the systems are connected. Same as that for this LAN also. In this LAN, inside this LAN, all the systems are connected to the LAN. And these two LAN which are present are connected with the connected device. This is known as the connecting devices. So these two LANs are what? These two LANs are connected with a device. So which device these two LANs are connected is known as the connecting devices. Now, there are three types of connecting devices present. That is what? Router, bridge, repeater, or hub, we can say. So repeater or hub, this connecting devices, repeater or hub, works on the physical layer. You see, this repeater and hub is only work on the physical layer. The bridge is another connecting device. This bridge works on physical layer and data link layer, both. This connecting device can work in both layers, physical layer and data link layer, in both layer also. And another is the router. This router can work in any of the layers, physical layer, data link, network. Any of the layer, router can work. So that's why router are work on all three layers. And that's why router is called three-layer switch. Router is called three-layer switch because it works on three layers. It can work on physical layer, it can work on data link layer, it can work on network layer also. So that's why router is called three-layer switch. Whereas bridge connecting devices work on physical layer and data link layer. So that means bridge can be called two-layer switch because it works on the two layer, physical and data link. Same as that, repeater or hub, it is called one layer switch because it only work on the physical layer. Huh? So that's why repeater or hub is one layer switch, bridge is two-layer switch, router is three-layer switch. Now what we will know that what are our repeater or hub, what will be the bridge, what will be the router. We will see the concepts of this. We'll see the concept of each of this one by one. So today I will not able to explain all this because the time is short, but that's also I am only saying our first connecting device, that is the repeater. But what is the purpose of the repeater? Repeater is the device operates on only in the physical layer, which we have already seen that it operates on the physical layer. And repeater receives a signal before it becomes too weak, corrupted, regenerates and retimes the original bit pattern. Now, if any signal is transmitting from a distance present and is transmitting on another location. So when a signal is transmitting, the signal has the tendency to become weak because whenever it covers the large areas, whenever it covers the large distance, so that time what happens? The signal, after covering some distance, the signal becomes too weak. The signal becomes weak. So repeater will do what? There will be a repeater present. Repeater will regenerate that signal and we will retain the original bit pattern. Now that means if we see through a diagram, it will be clear that there is a signal is going. You see, a signal is transmitting. Now, after covering this some distance, the signal becomes what? The signal becomes weak. You see, there is signal is that time very much strong, but this time the signal becomes too weak. Now, there will be the repeater present. So, inside this repeater, this weak signals will go on. And after work is what? It regenerates and retimes the original bit pattern. So if the signal is weak or corrupted, repeater will regenerate and retimes the original bit pattern. Clear to everyone?
Yes, sir.
Okay. So, हाँ, बोलो.
No, sir, clear.
सुचित्रा, उज्जवल, शीतल, क्लियर है?
Yes, sir. Yes, sir.
Okay. So this is about, next day we'll see about the hub, because today we'll not able to explain that. So in next day we will see for all this our connecting devices one by one. Okay. So now this is up to, in this class this is up to here. So everyone please scan the QR code to give your attendance. और एक बात हम आज डिस्कस कर देते हैं और बोल भी देते हैं, जो इम्पोर्टेंट तुम लोग के लिए है, वो है कि कॉलेज अब बहुत रूल्स रेस्ट्रिक्शंस लाए हैं, तो इसीलिए बोल रहे हैं कि जिसका अटेंडेंस, कॉलेज से ऐसे डिसीजंस लिया गया है कि जिसका अटेंडेंस कम रहेगा उन लोगों का गार्जियन के पास कॉल जाएगा एडमिन से, ठीक है? तो इसलिए अटेंडेंस इज वेरी मच इम्पोर्टेंट. जिसका अटेंडेंस 60% के नीचे होगा उसके घर में कॉल जाएगा गार्जियन के पास. ओके, इट इज क्लियर टू एवरीवन? हम सबके बात नहीं बोल रहे हैं, कुछ कुछ लोग हैं जो क्लास में रेगुलरली आते हैं, हम उसका बात हम नहीं बोल रहे हैं, बट some persons are there who are not coming in the class, like didn't want to mention those names, but this is gone that if the 60% attendance will not present, then the in your through, because the numbers are in the of your guardian's number is present in the admin, so from admin the call will be go to your parents. Okay.
हेलो सर.
हाँ बोलो.
सर अटेंडेंस सबमिट नहीं हो रहा है.
अटेंडेंस सबमिट नहीं हो रहा है?
Yes, sir. उसमें लिखा है you cannot enroll yourself.
ये डाक है.
Yeah.
1 minute. हम टाइम देंगे अटेंडेंस ये करने के लिए, कोई इशू नहीं.
सर आप दूसरा सब्जेक्ट का दे दिए हैं क्यों?
यस सर, दूसरा सब्जेक्ट का.
सर ये हम लोग का बैच का ही नहीं है.
19-23 का है सर.
अच्छा अच्छा. हम 5 मिनट्स टाइम देंगे, ठीक है? बट वन थिंग ये करना कि जिसका हम बोल देंगे, जिसका जो क्लास में प्रेजेंट है, ठीक है, वही अटेंडेंस देना. अगर हम किसी को देखें कि क्लास में जो प्रेजेंट नहीं है, बाकी किसी का अटेंडेंस हुआ, तो हम उसका अटेंडेंस माइनस कर देंगे, ठीक है? तो क्लास में जो लोग प्रेजेंट थे, और मेरे पास प्रूफ भी है, ठीक है, इसीलिए सिर्फ क्लास में जो लोग प्रेजेंट होगा वही अटेंडेंस देना. हम टाइम इंक्रीज कर दे रहा है थोड़ा।